Hello, my mathematicians. This is Miss Foster with Math in Focus, Grade 4, Chapter 2, Lesson 3, Multiples. Multiples are just the products of two factors. But looking at multiples and how the multiples of one factor compare to the multiples of a different factor, that is a relationship and series of patterns that can really help us when we're working to understand math deeply. So to find multiples of a number, you just multiply that number by any whole number. We're not dealing with pieces and parts. So this young friend is sharing with us the multiples of 3. And if we read them off here, you can hear the first 10 multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Thinking about multiples can also help us figure out a relationship between a possible factor and a larger number. So we can use division to see if one lower number is a factor of a higher number, and that higher number is the multiple. For example, is 12 a multiple of 3? Well, if I take 12 and divide it into 3 parts, the answer is 4. If there's nothing in the remainder, nothing left over, then we know that 3 is a multiple of 12. Is 28 a multiple of 3? Well, if I did 28 divided by 3, the closest I could get is 3 times 9, which is 27, and it has a remainder. If it has a remainder, then that number is not a multiple of the smaller factor. So let's give this a try. Is 24 a multiple of 8? Are there any multiplication facts for 8 that have a 24 as a product? Well, I happen to know, and I bet you've already thought of it, 8 times 3 equals 24. And so because there's nothing left over, no remainder, it is a math fact for multiplying 8, then that means that 24 is a multiple of 8. So yes. Is 42 a multiple of 5? Let me try division this time. If I take 42 and I divide it by 5, 5 times 8 is 40. Okay, so if I take the five groups and I take 42 and I put them into 5 groups, there are 8 in each group. But when I take those away and put them in those groups, there's something left over. The leftover here, the remainder, tells us that 5 is not a multiple of 42. So let's find the first 5 multiples or products of 6 times another number. To do that, it might be helpful for us to draw a table like this. We'll put a list of the factors that we're doing times 6, and we'll put the multiple below. So 1 times 6 is 6. 2 times 6 is 12. 3 times 6 is 18. 4 times 6 is 24. And 5 times 6 is 30. When we find the first 5 or the first 10 or even the first 12 multiples of a number, we always start with that number times 1. How about for 7? When I look at these questions here, they're asking what is the 4th multiple of 7, the 5th multiple, the 12th multiple. I think I should probably set up a table. That's much better. All right, here we go, guys. We always start with 1 when we're finding the first multiples, and that's nice because it gives us a shot of confidence. 1 times 7 is 7. 2 times 7 is 14. 3 times 7, 21. If we add 7 to this, can you find 4 times 7? 28. 5 times 7, 35. 6 times 7 is hard, but if I think of 7 as being 5 plus 2, 35 plus 5 is 40, and 40 plus 2 is 42. Let's remember those really flexible strategies we have. 7 times 7 is a square number. I love those, and I know that it's 49. How about 8 times 7? That's another really tricky one. 56. 9 times 7 is 63. And here it gets easier again. 10 times 7 is 70. 11 times 7 is 77. And if I add 7 to 77, I'll get the 12th multiple. Well, let's see. It would take 3 more to get to 80. So if I add another 7 but divide it into 3 and 4, 77 plus 3 is 80. and 4 more makes 84. Having written this all down and remembered my multiples of 7, now I can easily say what's the fourth multiple? 1, 2, 3, 4, 28. The fifth multiple must be right next door. That would be like 5 times 7, 35. How about the 12th multiple? Right here, 12 times 7 is 84. Another way we can use multiples is to explore the relationship between two factors. Finding the common multiples between 4 and 6 will help us see what they have in common. I'm just going to list them this time. First, the first 12 multiples of 4. Well, that's just like counting by 4s. That would be 4. Another way that we can use multiples is to explore the relationship between two factors. So here we're going to look at the first 12 multiples of 4 and the first 4 multiples of 6 and see which multiples they have in common. This time I'm just going to list them out for you. So the first 4 multiples of 4 are 4, 8, 12, 16, 24, 28, 32, 36, 40, 44, and 48. And the first 12 multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, and 72. So of these first 12 multiples, what do they have in common? Well, I'm seeing that they both have a multiple that's 12. They share the multiple of 24. 36 seems to be the same. Let me see here. In terms of these multiples, oh, there's one, 48. So we can say that the first common multiples of 4 and 6, looking at just their first 12 multiples, are 12, 24, 36, and 48. And there is so much going on here. Do you know what I noticed about these? 12, 24, 36, and 48 are all multiples of 12. And if we look at the least common multiple of 4 and 6, which means the smallest one, that would be right here. That is the smallest number that has both 4 and 6 as factors. So 12 is the least common multiple of 4 and 6. That's a relationship that helps me to understand the relationship between 4 and 6 a lot better. And let me promise you, it is wicked useful when you're working with division, multiplication, and fractions. So here they're asking us to find a common multiple of each pair of numbers. In this case, I could just multiply 3 times 4, and I get to 12. 12 is a multiple of both 3 and 4. So multiplying two factors by each other will get you a common multiple. How about 5 times 4, or 5 and 4? Well, 5 times 4 equals 20. So 20 is a multiple that they have in common. Now here's some good fun. We're going to use a variable. A variable is just a number that we don't know, and we are representing it with a letter, in this case, x. X can equal a question mark, like we don't know what that is yet. Or when you were littler, instead of using a variable, we just left a blank. So here we've got this riddle. Let's think about it together. 15 and 30 are common multiples of 5 and x, a number that we do not know. We do know, however, that x is a one-digit number, and they tell us that x is not 1. So what number could x be? Well, let me see here. 3 times 5 is 15, and 3 times 10 is 30. So could the number be 3? Yes, and I was able to find that because I know that 5 times 3 is 15. So, and then think, could 3 be a factor of 30? Yes, 3 times 10 is 30. So we've got to use our multiplication knowledge to figure out riddles like this. So with this question, they're asking us to find the first 3 common multiples of 3 and 7. They've also asked us to make a list of the multiples of 3 and 7. So I've done that for you. Multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. The multiples of 7, I will tell you, was a little bit more challenging for me. but I found them. 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70. But what are the first three common multiples? And I noticed that the least common multiple for both of them is 21. But for me to use these lists to figure out what their next biggest common multiple is, that seems like I'm going to have to write a lot of multiples. What if instead I say that 21 is their least common multiple, which is 7 times 3? What would 21 times 2 be? 2 times 1 is 2. 2 times 2 tenths is 4. So 42 is the second highest multiple of 7 and 3. What about taking 21 and multiplying that times 3? We know that 3 and 7 are factors of 21. So that 21 times 3 will also give us a common multiple of 3 and 7. 3 times 1 is 3 in the single ones place. 3 times 2 is 6 in the tens place. Wow! So we can also use longer multiplication to help us find multiples. Friends, this is how we can really explore relationships between two numbers. Do they share common multiples? What is their smallest one? And that helps us to understand numbers and their relationships and look at their patterns better. Now, I noticed that for me, I was going through my multiplication facts a lot. So I hope you noticed that we were doing that. This kind of analysis gives us a fabulous, authentic way to really practice our multiplication facts. I hope this inspires you to keep practicing them and to use every part of these assignments in this lesson to really get to know your multiplication facts even better. Hey friends, thanks for playing with multiples with me. I love playing math with you. Bye-bye for now.